Hello student, welcome to our discussion that is physics in a smart way. Today we shall discuss on projectile motion. Our last video was also on projectile motion. And the main agenda of today is that once you get a question, you should not immediately jump into the solution right in the earnest. The best way would be, we got the question, think about it for 10 or 20 seconds or 30 seconds. Try to find out the number of ways available to solve the particular question and then select the way or the style which requires least effort. That will be the topic of today's discussion. I have taken up a question from the great book that is Physics by I. Rodolph. Okay, the question is in the light of that, and we shall discuss the question and we have to go through it. Let us go through it. The question says, from the top of a mountain, a ball is thrown with a speed of 20 meters per second at an angle of elevation of 30 degrees. Find the time at which the velocity of the ball becomes perpendicular to its initial velocity. The velocity vector of the ball should be perpendicular to the initial velocity vector. Okay, now coming back to the angle of elevation. Angle of elevation, angle of depression, they are always measured with respect to the horizontal direction. If a body is thrown upward, then that is the angle that makes with velocity, makes with or propagation direction, makes with horizontal, we brand it as angle of elevation. If it is thrown downwards, then we say it is angle of depression, the angle that the velocity or the projection direction makes with the horizontal. So this, in our case, theta is given, angle of elevation is given as 30 degrees. Okay. So as we have discussed the question, let us say we get to the solution. We get to the solution and say we consider the first procedure. Because the condition says what will be the time of travel starting from the start of the motion when the velocity vector becomes perpendicular, we put emphasis to that perpendicular condition. I believe most of you remember that if two straight lines are perpendicular to each other, then their slope product will be -1. I have taken a line number 1, imaginary line number 1 along initial velocity, another line number 2 along the final velocity. If their slopes are m1 and m2, then we do know that as the coordinate geometry says, the slope product, if the lines are orthogonal or perpendicular, must be -1. That must be the basic condition. I think you know it. If not, then go through those issues of coordinate geometry. Those are simple issues, small issues. So far as M1 is concerned, you know that is the slope of the first line along which lies the initial velocity, which makes an angle theta. So we know immediately that M1 must be equal to tan theta, because theta is given to be 30 degrees, then M1 is known. Now we try to go to M2. Some of us might be tempted, so to say, to put in the value of M1 tan theta here and find M2 as -1 by tan theta, that is minus cos theta. But doing that will solve no purpose. Our question asks us the time. Okay, if you exhaust the condition here, then you got nothing else to move on. So initially we must keep this in reserve for future use. We try to find M2 using other ways, using other means of, of the study of motion that is at our disposal. Try to find M2 independently, separately from other sources. And when you stuff in the values of M1 and M2, M1 is waiting. So the moment we find the value of M2, then put in there, and the right hand side you get -1. From that we hope to find something, especially the time of travel or whatever it is. Let us say the time of travel is t, starting from the start of the motion, that is S to P. Okay, P is the point where we see the velocity vector becomes perpendicular to its initial velocity. We have to be observant from the start of the motion. Every instant you have to check the velocity. It was not perpendicular, say from here to here. Only exactly when we arrive at P, we see that velocity becomes normal to our initial velocity. Okay. Now, because the velocity we have branded as V, we do not know the value of V at the moment, but we know this velocity, if that makes an angle alpha with the horizontal, in trigonometry sense, alpha is negative, we don't bother. Automatically that will be coming out negative. And along the final velocity, we know second line lies. So to write M2, we got no problem here. We can brand it as tan alpha. But writing in this way will be also solving no issue or will be of no help because alpha is unknown. Okay. To determine alpha or to determine tan alpha, we go back to the final velocity again. We have drawn the final velocity and its horizontal and vertical component. I am sorry, I have not marked my x and y directions. We consider x-axis along the horizontal and y-axis along the vertical. So horizontal component of velocity Vx and vertical component of the velocity Vy we have marked. And if you try to present Vx, Vy and V, the components of V and V itself in a vector triangle, then you know the things will be coming in that way. And this angle is alpha. They will be same. Tan alpha, as it seems, that is the ratio of Vy by Vx. So now we see a hope. Once you get hold of Vy, once you get hold of Vx, then tan alpha can be known, M2 is known, and then we can utilize the condition. But we have to work a bit more. If we go to the denominator here, Vx, that is the x component of the velocity here, the velocity V, and we know x component means horizontal component. Horizontal velocity never changes. We do know that horizontal acceleration is nil. There is no horizontal acceleration. There is no horizontal force to change the horizontal velocity of the projectile. So in place of Vx, if I write Ux, that is initial velocity x component, we know that must be true. Of course, we have to break down initial velocity into its x and y component. So we modify the diagram accordingly. So initial velocity is u, its x component is ux, y component is uy. And everybody knows, all of you do know, because initial velocity u is given, angle theta is given, ux must be equal to u cos theta. So that is By. Again, I am sticking to the numerator. Ux is equal to u cos theta. We can put it now. I think you are clear. Now you come down to the numerator, that is By. By cannot be mentioned simply as Uy or something like that. That is, as easily we have done for horizontal component of velocity, the vertical component or vertical motion is not so simple. Yes, it is not so difficult also, but that is not so simple that you just say Vy equal to Ui or vertical velocity doesn't change. That won't work. We know that's not true. To find out Vy, we know our initial vertical component of the velocity is given. Because Ux equal to U cos theta, then Ui must be equal to U sin theta, and that is in upward direction. We consider upward vectors positive. We consider upward vectors positive. Okay. So far as in most of the cases of vertical motions. So to find out Vy, we now take a heading that is vertical motion. That is vertical motion from your, that is starting point to point P, from S to P. So if you take the vertical motion and under that we put a equation that is V equal to U plus AT, automatically the equation means the terms of the equation they should mean V means velocity here, but under this heading V is vertical velocity and V is final vertical velocity, and you know the final point is point P. So automatically V means that is Vy. U is initial vertical velocity, that will be equal to Ey plus A. We know A means vertical acceleration. Immediately G will be jumping down to take its place into T. Time has got no vertical and horizontal. Time is independent of all those things. So next step, we write By equal to Uy. Uy equal to U sin theta. We know Uy equal to U sin theta. Okay, and that is upward. It is considered as positive. Or else you could have written U sin theta j cap. But we are not using that style now, readily. Plus our Ay is G, but you know G must be taken as a negative vector. So minus G into T. So thereby that becomes your U sin theta minus GT. Okay, that is the value of By. So now we stop in here, the place where we have left at. Sorry. Okay, I got distracted for a second. Okay, so I beg excuse. So now if you put in the value of Vy, then that is equal to U sin theta minus GT. Okay, and we cannot move further. That is the dead end. So now we see we got the value of M2 in the form of a bit, it's slight bit larger form, U sin theta minus GT by U cos theta. Now the time has come to utilize our condition. We do know that because M1 into M2 equal to minus 1, M1 equal to tan theta into M2, we got a big term that is U sin theta minus GT, okay, by U cos theta, and the product must be equal to minus 1. You don't have to do more. In fact, physics is over. Now whatever you are doing is school level mathematics, that is trigonometry. We break up tan theta as sin theta by cos theta. So sin theta by cos theta, we break it up, okay, within bracket, U sin theta minus GT by your, divided by your U cos theta should be equal to, that is minus 1. What we do, we try to cross multiply, take the numerator, open up the bracket in the numerator and take the denominator to right hand side. So that implies your sin theta into U sin theta minus GT must be equal to, at the other side will be having minus, the minus 1 is there, cos theta into U cos theta. Okay, clear? Now one step you have to go. I won't be going to that step. You do yourself. We take sine theta or open up the bracket. There is only one unknown, that is time. Separate out that is school level mathematics. When you separate out time, the time comes out to be u by g sine theta, because u equal to 20, g value equal to 10, sine theta equal to 1 by 2. So answer comes out to be 4 seconds. Please check it yourself. I am giving you 10 seconds. Meanwhile, I am having coffee. Okay. But one thing, ladies and gentlemen, if you try to look back, the job that we have done, can it be completed? Can the entire solution be completed in a time as small as 1 minute? That is, the time of 1 minute is the regular time we get for all of our entrances, maybe JEE, maybe medical entrance and all that. And this is a big solution. Some of you might be tempted to brand this solution as a long question or something like that. So let us say we try to view the situation from another perspective. There is a second way. Okay? There is a second way. Okay. Ladies and gentlemen, now let us look at the question at a slightly different angle. I have drawn a simple sketch of the situation. I have not drawn elaborately, only u, the initial velocity, final velocity, angle theta and alpha, they are shown. And because you have seen the diagram, you have understood the question, then it won't be a problem. Now, if we come back to the condition of the question, that clearly says initial velocity vector and final velocity vector, they must be perpendicular to each other. We go back in memory to our early days of 11th science, that was the issue of scalar and vectors. And there we do know when two vectors are mutually perpendicular, their dot product will be 0. Their scalar product will be 0. That means initial velocity vector dot final velocity vector must be equal to 0. I have given the arrow signs, vector signs. Nowadays, most of the books, they do not give these signs. Okay. But I am an old timer. My point is that everything that is meant for the student should not confuse the student. So here we take them strictly as vectors. Strictly as vectors. U dot B vector equal to 0. Okay. Now, if I consider the motion from S to P, that was the starting point S, here the point P, their velocity is normal to initial velocity. So motion from S to P, and mind it, in the last case or in the last method, we had taken the vertical motion. So here we do not take the vertical motion or horizontal motion, we take the complete motion from S to V. Okay, so velocity is present or anything present are not, they are X and Y component, they are complete vectors. We got the equation V equal to, that is U plus AT. In pure vector form, it must be like that. Final velocity vector must be equal to initial velocity vector plus acceleration vector into time. Next step, we do know that V vector will be equal to U vector plus the acceleration which controls the entire planetary motion. We know that is nothing else but gravity. So we say that is G vector into time. Okay. And if gravity complains, like you are taking my name and you have not mentioned it, we may allow gravity to hang down from here. Say G is like that anywhere, you do it. If this angle is theta, then you know this angle will be 90 minus theta. All these things are clear cut, they may not be required. Okay. Now, we got this equation, we try to stuff in here. So when you try to stuff in here, in place of velocity, final velocity vector, we put in here, the next step will be that u vector dot b vector comes out to be u vector plus g vector into time, and that must be equal to 0. The next step will be open up the bracket. So that is u vector dot u vector plus u vector dot g vector into your t must be equal to 0. Next step will be u vector dot u vector, that is u magnitude square, that is u square, plus u vector dot g vector. We do know u vector is a vector that is like this. Okay, g vector, I make it to be placed here. If you consider the angle between them, because the scalar product, we know a dot b vector must be equal to a magnitude into b magnitude into cos of the angle between them. The angle between the two vectors u and g, that seems to be theta plus 90 degree. So I put in there, that is u magnitude into g magnitude into cos 90 plus theta. Of course, that makes it minus sin theta into t equal to 0. So thereby cos 90 plus theta, we know that is minus sin theta. So that is equal to u square minus ug into sin theta into t will be equal to 0. Take this to the right hand side, okay, and separate out time. I am also skipping a step, separate out time. Time will be 1u will be cancelling out, u by g sin theta, and when you stuff in the values, we'll be getting the same old answer, that is 4 seconds. I think it is clear. And if you compare with the last solution, method 1, we know the solution is somehow reduced. That is reduced, okay? And will be taking lesser time. But our discussion is not over. Let us try to look at the situation through or in another way. Okay. Now, say we consider the same question in another way, that is method 3. Try to think it over. Normally, when you consider x component of motion, y component of motion, we do reserve those x and y directions for horizontal and vertical direction so far as projectile motion is concerned. X-axis is taken along horizontal and y-axis is taken along vertical. But tell me, is it obligatory? Is it mandatory? Is it a Supreme Court rule that we are obliged to take always horizontal and x-axis and vertical along y-axis? No. Only condition that you cannot violate so far as x and y axes are concerned is that angle between the x and y must be remaining 90 degree. If you make the angle between x and y other than 90 degree, in some rare cases I have seen, those are done in mathematics, but not too often. If we do not make angle between x and y as 90 degree, then they do not become independent direction. Happenings in x-axis will be controlling, will be somehow having some effect on y-axis. But when you make angle between x and y, or keep the angle between x and y as 90 degree, then x and y directions, they become independent. You can study them separately. When you consider x motion or x something, you don't have to think about y. When you study similarly the y motion or y something, then you do not have to think about x. Otherwise, It is not necessary, it is not a stipulation, it is not or that rule cannot be, or such a rule cannot be forced upon us, which says x-axis we are always to take along horizontal and y-axis vertical. Because it is convenient to us, we are considering horizontal along x-axis and vertical along y-axis, but it is not obligatory. It cannot be forced upon us. I am changing the style. I consider, let us say, initial velocity and x-axis in that direction. I consider x-axis along initial velocity. So obviously, because v is perpendicular to u, y-axis must be falling along final velocity. So somehow the axes, they cross each other. This point can be taken as origin or something like that. It is not so necessary. So x-axis and y-axis. Please look at the picture more clearly and have a bit more focus. We consider x-axis along initial velocity and y-axis along the final velocity. That is the starting point of the motion, that is S, and this is the finishing point, that is P. Okay, and the projectile motion is from S to P. Okay, that is like this. We may draw it or not, but we know about the motion. We have seen the diagram. We have seen the motion, at least in some two separate cases. That won't be confusing us. Okay. So here, what I consider is motion from S to P along x-axis. Motion from S to P along x-axis. Think about that. Focus on that. I am considering x motion, and from starting point to point P, beyond P, what the body does, it is of no concern. And you know, time of travel is T. Okay? But time is independent of x and y or whatever motion we take, time is independent of those. And I consider V equal to U plus AT. Some of us might be having some questions in mind that are we eligible to use this equation under such peculiar conditioning? No. We know the projectile motion or any of its component, any of its resolution, any of its parts is a motion with constant acceleration because the overall control is with G. Okay, and because G is a constant acceleration, any component of G is supposed to be constant. Any component of G. So any direction we consider the motion, that will be a motion with constant acceleration. I think I am clear. So thereby we are eligible to put the condition V equal to U plus AT. But now tell me, what does this or what is the meaning of the terms in this equation? We are studying motion along x-axis. So here V means specifically that must be taken as Vx, x component of the final velocity. Because we are studying exclusively x motion, we are not studying motion along any direction. So V means Vx, x component of the final velocity. U means Ux, x component of the initial velocity. A means Ax. A means X, I am skipping a step. A means X, X component of acceleration. Because you know overall acceleration is G. So if somebody in place of X, he or she write Gx, he or she is perfectly eligible. So in place of X, I write Gx directly, thereby skipping a step. I think I am clear. Now, think about Vx. Vx means final x velocity or the final velocity's x component. We know As the diagram clearly shows, the final velocity is along y direction. The final velocity is along y direction, and you know a pure y vector, a vector which lies along y-axis, maybe positive y, maybe negative y, doesn't matter, but its x component must be 0. A pure y vector has got no x component or 0 x component. Similarly, a pure x vector has got no y component, no z component. We do know that. So because final velocity is perfectly along y direction, so its x component must be 0. Okay, now come down to ux. Ux means initial velocity is x component. We know initial velocity is perfectly along x-axis. So its x component must be itself full u. So in place of ux, we are writing u. Clear? Plus gx. Gx means the x component of g. We know our acceleration due to gravity hangs down there. So gx must be g's x component, because this angle the g makes with x direction is 90 minus theta. So gx must be g cos 90 minus theta. G cos 90 minus theta. Okay. And there is one thing more. We know that is positive x direction. That is positive y direction. If it is positive x direction, u will be taken as a positive vector, but g's x component you can clearly see is in the negative x direction, that rather opposes u in place of helping you. So thereby that must be coming down with a minus sign. So gx must be equal to our, that is minus g cos 90 minus theta into t. So next step will be ours 0 equal to u cos 90 minus theta is sin theta with a minus sign, u minus g sin theta into t. And next step, that gives you the answer. If you separate time, getting the second term to the left hand side, t comes out to be u by g sin theta. Okay, now you got the solution. And you can clearly see when we have come down from method 1 to method 2 to method 3, the span of the solution is drastically reduced. Okay? And at this stage, it can be taken as a perfect multiple choice type. Of course, to explain the things, I have gone through several steps and all those things. Many of the steps could have been skipped, and you could have gone for the solution within 2 or 3 steps maximum. So time equal to u by g sin theta, which you know as the numerical value is 4 seconds. We do know. We have got that in the first and second method. Okay. You can clearly see the elegance of the solution with a slight bit of change in our thinking. It reduces our solution. So here, I would like to repeat my advice to you. Whenever you are getting a question, you are getting a problem, don't jump into the calculation blindly. Think about that. Take 10 seconds, take 10 seconds, take 20 seconds. Even if you take that time at entrance level, it won't be a loss, because maybe there is a simple solution available and you have unknowingly gone through a difficult procedure, and that kills your time. Okay, I think my point is clear, but some of you might be questioning me in the way that, sir, you know the solution, you have gone through, and we see the solution span is reduced. How can a student solve it? Which the student who have got no initial knowledge on all those things. So I am going for a fourth method, that is student-friendly approach. Even if you are not well versed Okay, let us get to method 4, which may be to your liking. I hope so. So we have shown initial velocities and final velocities, angle theta, alpha, as you have seen previously. Initial velocities use x component, y component. The final velocities x component, y component. This point is S and that point is P, as we know before. Now we go for some calculation. If you like, you can work it out with symbols. If you like, you can work it out with numbers, both ways. But at least the last 3 methods, we have worked with symbols. Let us say we work with numbers. Ux equal to, we know because u makes an angle theta with x-axis, u cos theta, u is given as 20, and cos theta will be cos 30 degree. Cos 30 equal to root 3 by 2, so that must be 10 root 3. We don't need to break down root 3 into 1.7, 32, something like that. There is no need. Vx, sorry, I have done a mistake. I must remove it. Okay, that is not Vx, that is Uy. Uy will be equal to U sin theta, and because U equal to 20, sin theta is sin 30 degree. We know that theta equal to 30 degree, so that must be 20 into 1 by 2, that is 10. Say meter per second, that is meter per second. Okay, when you are writing fast, you can dispense with the writing the units and something like that, because already you have crossed that stage. We know the unit of velocity and all that. So now thinking of ux equal to 10 root 3 and uy equal to 10 root 3, sorry, 10, that is 10 upward. If you now connect u and v, we know so far as horizontal motion is concerned, u and v, initial velocity and final velocity, they are connected in such a way that the x component or horizontal component of velocity that never goes through a change. So once I got ux equal to 10 root 3, then blindly I can write Vx also equal to 10 root 3 because Vx is horizontal component of the velocity. And at the same time, we know that final velocity makes an angle alpha with the horizontal. Using our elementary idea of geometry, we do know alpha will be equal to 90 minus theta. Because theta equal to 30 degree, so alpha becomes 60 degree. So this angle becomes 60 degree. Okay. If I write now the final velocities x and y component, final velocities x component Vx will be equal to, in symbols, in terms of V and alpha, will be equal to V cos alpha. Okay, that is V cos alpha equal to cos 60. Cos 60 equal to 1 by 2, that is B by 2. And we do know, already we do know that Vx equal to 10 root 3, Vx equal to Ux. So we can put in that 10 root 3, from which immediately V will be apparent, V equal to 20 root 3. Is it clear? Meter per second, obviously. Now going for other part of the velocity, as per the formula, component formula, that will be equal to V sin alpha. We know V, already here we got that is 20 root 3. Sin alpha, alpha is 60 degree and sin 60 equal to root 3 by 2. So thereby that becomes 30 meter per second. Is it clear? Okay, so Vy we got as 30 meter per second. Okay, now V is y component and x component, they are known. We don't have to do anything much more. We just consider vertical motion. If you consider vertical motion, in case of vertical motion, from starting point to point P, okay, and we just consider V equal to U plus AT. We know our old sign convention is still valid. Here also you can take the help of I cap, J cap, K cap, but I'm not going through that. Simply putting a plus minus sign, upward vectors positive. Here V means final vertical velocity. V is final vertical velocity. Final vertical velocity, that is Vy, or if you write a step more, then V equal to Vy. U here becomes Uy. A becomes Ay or Gy into Ut. Vy is 30 and downwards, so that will be treated as minus 30. Uy, U's y component will be 10 and upwards, that is plus 10. Plus vertical acceleration, we know that is g, and downward and negative, that is t. So here t comes out to be 4 seconds. That is a very much student friendly solution. Knowing or treating the things, or simply the knowledge of your components and all those things will be helping you in solve it. At last, if you like, you can go for one or two more different processes, but I won't be elaborating. Video will be too long, but mind it. So far as these videos which I am presenting nowadays, of course, my plan is to start a complete set of videos along with the theory and questions, so that a student will be self-sufficient if he or she goes through those videos. But that will be later on, after a month or so, as I plan. But these videos, they require a just basic knowledge of the motion concern. If you just have got idea on projectile motion, then these videos will be very much helpful to you. So before coming down to the topic, or my videos goes through the issue, if it is possible, at least you must be aware of the formula, aware of the principles involved at the basic level. So they will be very much helpful for you at entrance level or at bit advanced level. So thank you, but don't forget, if you like, or dislike, if you dislike, and share and subscribe my channel. If you want to get the full benefit of it. Thank you again. Have a good day, ladies and gentlemen.